Well, greetings. Here we have a fun little problem. We have a triangle. We know all three sides. Can you find the area of the triangle? You do not know any of the angles to begin with. You could find one, and that will take a little work, but you don't really need to do that. So we're going to run through this in three different techniques. One, we're going to use a simple formula. One, we're going to use algebra, and one, we're going to use a technique that requires trig. I realize not every one of you knows trig, uh, and so we're going to start with the simple formula that everybody can handle. And then we're going to get into the other techniques. So, what is the area of a triangle given three sides? And you don't know any of the angles to begin with. One way is to solve this problem is to use the law of cosines, but that requires trig. And we would then find an angle. Then we would find the height of the triangle using the sine of the found angle. But since not everyone has had trig, we're going to put that off to third. Another method is to use the height of the triangle to separate the base into two parts, x and the value of the base minus x. Making the height h, use the Pythagorean theorem twice, then solve a system of two equations with two unknowns. Now, there'll be square terms in this system, so it's a nonlinear system. That turns out not to be too bad, and it can be handled rather easily. But first, we're going to start off with a nice, simple formula. Here, we're going to avoid all the issues with our first solution and opt for Heron's formula. Heron discovered this formula many years ago, and it's commonly called Heron's formula or Heron's formula. You can find it under two different spellings. This one appears to be prevalent at this time. So Heron's formula, we have a triangle, A, B, C, and we're going to label the sides across from the angles A, B, C. That really has no bearing on anything what we call A, B, or C, as long as we have all three sides. So the first thing Heron requires us to find is the half perimeter. A half perimeter is one half the perimeter. So we call that S, and that's going to be one half the sum of A, B, and C. So we're going to take three sides, add them together, and divide by 2. That's an easy operation. Then Heron's formula says the area of the triangle is the half perimeter times the half perimeter minus A times the half perimeter minus B times the half perimeter minus C. So we have three subtractions, and then we have to multiply four numbers together, and then we have to take their square root. Now, I'm going to tell you right now that when we deal with the square root, I delegate that to my calculator. So I suggest you go ahead and do the same. Find the area. Trig not required. So first we find S is 1/2 15 centimeters plus 20 centimeters plus 22 centimeters. Okay, and that's 28 and a half centimeters. So I think I put C and B out of order, but it really doesn't matter. So now I'm going to take the area and yeah, I think I did put them out of order, but that's okay. So it's 28.5 centimeters times 28.5 minus 15 centimeters times 28.5 minus 20 centimeters times 28.5 minus 22 centimeters, which is 28.5 times 13.5 times 8.5 times 6.5 centimeters to the fourth. They have centimeters times centimeters times centimeters times centimeters. Well, that's convenient because the square root of centimeters to the fourth is centimeters squared. That happens to give us an area type unit. And if I multiply these numbers together, I get 21,257. So I'm going to take their square root, and I come up with about, and I did some rounding, 146 square centimeters. I don't have any problem with rounding here because all of the measurements in the triangle started off to two significant figures. And so that means that if we were using a real world triangle and we were making measurements, the last digit is always doubtful. So we always wonder if it's exact, and it often isn't. And so in the real world, we have two significant digits. And so I'm going to round that 146 to 150. Two significant digits. The trailing zero here is not considered significant. Square centimeters. So sometimes students will struggle with the significant digit part, and they'll be working a problem in the textbook and look at the back of the book, or if they're working with a book that has software with it, they'll plug in a number and they'll tell them they have an error. A lot of times they've done the problem right, except they haven't kept the right number of significant digits. And so sometimes that gets to be a little issue with whether or not a textbook will accept your answer. Okay, well, that was the first technique, and it was simple and straightforward. For the algebraic technique, we're going to use the Pythagorean theorem twice. And for the trigonometric technique, we're going to use the law of cosines, and we will need to find the triangle's height. And so I'm going to show you an image here of our triangle. We don't have the numbers in, but we're going to have to construct a height. And we're going to use the basic triangle area formula that most people know. Area is 1/2 the base times the height. In this case, I selected AB as the base, so it's 1/2 the segment AB's length times the height H. Now, when we do this, I have perpendicular line segments here, because the vertex across from the base is the shortest distance, which means these must be 90 degrees, these two angles. So angle D, ADC and BDC are both 90 degrees. So now we have two Pythagorean triangles, two 90-degree triangles that we can use the Pythagorean theorem to find. So I'm going to call this side X, AD is X, and AB is the entirety of this line segment minus X. So the two have to add up to the length of AB. So if I'm going to have X on one side, I'm going to have the total length minus x on the other. And so here we put our numbers in, and our base is going to be 20 centimeters. These two numbers, 22 centimeters and 15 centimeters, are going to become hypotenuse of triangle ADC and hypotenuse of BDC. But that's coming. So right now we're going to write, using Pythagorean theorem, this side, if you recall, I called x. So x squared plus h squared is this hypotenuse, 22 squared. And this side was 20 minus x. The length of AB minus x is 20 minus x squared. Again, plus h squared is 15 squared. So I have two equations, and I have two unknowns, x and h. Well, these are not linear equations, but it doesn't matter. And this is one of the reasons why you learn various techniques for solving systems of equations. In this case, substitution is going to work real well. Now, if I substitute for x, I have to take this, get x by itself, take the square root, plug it in, square the whole thing, and I'm going to end up with a mess. H squared can be substituted for h squared. I don't have to take the square root, plug it in, and then square it. I can substitute directly for h squared. So that's what I'm going to do. I'm going to solve this equation for h squared and plug it in. Saves me a lot of time and effort. So here are my two equations. I'm going to solve the first one for h squared, and it's going to be 22 squared minus x squared. So here I have 20 minus x squared, and I'm going to put in 22 squared minus x squared right here for h squared, and that's equal to 15 squared. So there we have our little equation. You say, well, but I want h. Sometimes it's easier to find x and then do a substitution later. In this case, I would rather find x than h first. So I can expand 20 minus x squared is 400 minus 40x plus x squared. And that's just multiplying 20 minus x by itself. And then I'm going to add to that 22 squared, which is 486, minus x squared, and that's equal to 15 squared, which is 225. Now, if you wanted to carry centimeters through every step, that's okay. Sometimes people have teachers that require this. We know what's going to happen. We're going to get centimeters in the end, and our areas can be in square centimeters. So I got to solve this for x. Well, conveniently, x squared and minus x squared equals 0. And so that goes away. We don't have that part. We got an x term and three numbers. So we're going to isolate our three numbers, 400 plus 486 minus, because it's on the opposite side, and so the technique is to subtract 225 from each side, minus 225. And then I'm going to add 40x to each side, and I'll go away on the left, and it'll be 40x on the right. There's nothing magic about solving for x on the left. X, if we got two things equal and one of them's named x, it doesn't matter which side of the equation it's on. So if I add these three numbers, 400 plus 486 plus a negative 225. Technically, we add, or if you want to call it, do it as a subtraction, that's fine. Subtraction is actually a convenience in algebra. We add negative numbers. But then we divide that number that we get here by 40, and we get x is 16.525. Nice little number. Well, that's x. What we want is h. So we're going to pick the easier of the two equations. X squared plus h squared equals 22 squared. And we're going to solve that for h. H squared equals 22 squared minus x squared, and x is 16.525. So I had to subtract x squared from each side, and I plugged the number in. And so h squared is about 210.92. Now, when I start multiplying 3 decimals by 3 decimals, this thing is going to get pretty big in length. Not a bigger number, but in number sense, but a bigger number of digits, a larger number of digits. So I rounded off here. I'm going to take h to be about 210.92 to the 1/2 power, or the square root of 210.92. And that's going to come out about 14.52 centimeters. Now, I have that just gives me h. I have to find the area. And to find the area, we're going to use a pretty well-known formula. The area of a triangle is 1/2 the base times the height. Now, we have a base of 20. We got a height of 14.52. And we're going to do 1/2 the base times the height. There's no need to do 2 right triangle areas and put them together. We're going to just take the whole base. We're going to take the height, and we're going to do 1/2 the base times the height. Well, 1/2 of 20 is 10. And 10 times 14.52, that's 145.2, which I just rounded off to 145. And actually, since it's a little bigger than a 5, I see I have dropped the 2. I'm going to make that 150 centimeters to 2 significant figures. This 145, I remember I had done a little rounding in the process, and so it might have been 1 digit, one unit off of the 146 we found with Heron's formula. That's fine. That's round off error. And since we're going to make it 2 significant figures, this comes out to be exactly the same thing. Well, this turned out to be not too difficult. Sometimes when we start seeing x squared and numbers minus x quantity squared and so on, people start panicking. Don't panic. Just go through very orderly, and sometimes wonderful things happen, like the x squared terms just happen to cancel out, and you have the whole problem ended up solving a linear equation. Well, that's not too bad. Our third approach is to use the law of cosines to find an angle. Which one I pick is up to me. I don't care which one you pick. And then the sine function to find the height. So this is where we start. We have 3 sides. I'm going to find angle A. Nothing magic about angle A, but that's the one I've chosen. Now, I'm going to first use the law of cosines. And then I'm going to have my height here. Remember, I'm going to have that height here, h. I'm going to use this angle, the sine of this angle, which is opposite over the hypotenuse. And once I have the angle, I have the sine of the angle easily enough. Is h over the hypotenuse, and I would simply have to multiply to get the height. And then I can use the same formula that I already used, 1/2 the base times the height. So this is going to be the final formula. I'm going to use base AB. I'm going to use the height here, just like I did. I don't really need to know what the name of this is. I don't even need to know what X is. I'm going to use the law of cosines. This just as well not be here. This just as well, you can name it if you want. I don't care. I'm going to find the angle A using the law of cosines. And then I'm going to use the sine h over b and solve that for h. And then I got the h for here. I already got a AB. So AB, the length of the side. So that's going to work out. So the law of cosine says I take one side, the side opposite the angle I'm interested in. So here's the angle of interest, or the angle. Sometimes it's the angle you have. In this case, the angle I want. The side opposite, square it, a squared, equals the sum of the squares of the other two. So this is b squared plus c squared minus 2, these two angles, BC, times the cosine of the angle between them. Okay, so it happens that if the cosine is 90 degrees, if we were to have a right triangle, the cosine of 90 degrees is 0, and look at what you end up with is the Pythagorean. So here this is sort of like a Pythagorean with a general angle, if you wish. It's the relation of the three squares, and then we got this extra little multiplier times the cosine, and we can solve any triangle. Don't have to be a right triangle now. So I'm going to solve this for the cosine of A. So I got a squared equals b squared plus c squared minus 2bc cosine A. So I'm going to solve for cosine of A, and I get a squared minus b squared minus c squared, getting those to the other side. And I have to divide by, I have a negative 2bc. So negative 2bc. Okay, I could have manipulated the signs. I got a plus sign here, a negative here, and plus here, and a plus here. It doesn't matter. So, plugging the numbers I have in here. A, the side opposite, is 15 squared, minus 22, I'm going to have these two numbers, the 22 and the 20, 22 squared minus 20 squared, divided by a negative, and I still have to use these two, 22 and 20, the product of 22 times 20. And if I crunch this with my calculator, I rounded this off. It's approximately 0.7489. I wanted to keep enough digits that it didn't get too far off, but I'll do the rounding in the end. So to find the angle A, I have to take the arc cosine of the cosine. The arc cosine is the inverse function. The inverse cosine function of the cosine function just gives me the angle. And so that's 41.5 degrees. So taking the inverse function of 0.7489, so gives me 41.5 degrees. So I would plug this in where I see cosine, right here, and I would end up with 41.5 degrees. Well, all that is just to help me find H. So if I have the angle of 41.5 degrees, then the sine of the angle is the side opposite over hypotenuse. So the sine of A is H over B. And so I'll multiply both sides by B, and I get H equals B sine A. Okay. So H is 22, B sine 41.5 degrees, or about 14.6 centimeters. So say, well, okay, that gets me H. Now I need to find the area. And I'm going to use the area formula, 1/2 the base times the eighth, the height. So A is 1/2 times 20 times 14.52. Well, this is an easy calculation. I didn't even use my calculator because I divide 2 into 20 and I get 10. 10 times 14.5 is 145. And notice that this was a little bit more. I had an extra 2. So I got 145 centimeters, which I'm going to round off to 2 significant figures. So since this was actually greater than 5, it rounds off to 150. If it's exactly 5 and there's a bunch of zeros, there's different conventions on how one would round. Some people always go up. Some people go up half the time and down half, depending on whether they're going to end up with an even or an odd number in the digit before. But since it's more than 5, we are forced to round up. And so we don't get any issue. So we have 3 different techniques, and we ended up with the same answer 3 times. 145 and 146 because of round off errors that we used, and you can see that will cause a little bit of a discrepancy in the last digit. But when we go to significant figures, we always ended up in the same place. So we solved the problem. We found the area. We didn't need an angle to start with. We did have a method to find an angle if we wanted to use trig. We had a method to use algebra. But really, let me recommend Heron's formula. Learn it, and it will serve you well. And you can use it even before you have algebra. Well, thank you for watching, and please subscribe to the channel. I have other problems, and this one's a little bit longer than some, but I have other problems, and I have some theory, and I have some practice sets, a lot of videos that you might want to make use of. So thank you, and please consider the others.